Okay, so this is problem number 24 for the bonus problems for exam 2. This problem is asking us how much thermal energy is required to heat all of the water in a swimming pool by 1 degree Celsius if the dimensions are 4 foot deep by 20 foot wide by 75 feet long. So we're talking about thermal energy here. So we're talking about an equation that we need to focus on here. And the equation that we use is Q, which is the heat. And we're going to talk, the equation for this is going to be MC delta T. So M times C times delta T. Now M is going to be the mass. C is going to be the specific heat. Delta T is the change in temperature that we're going from. So let's consider the facts of what we've got here so far. So far we know, well, we don't know a mass. We've got to figure out the mass. Do we have a specific heat? Well, we're talking about water here. So water has a specific heat. And in that specific heat, water's specific heat is going to be 4.184 joules divided by grams times degrees Celsius. So this is the specific heat of just regular water. Now let's look at the change of temperature. Do we have that? We do. We're increasing. It says increase to a degree. Well, it doesn't really specify increase, but we're heating it. So we know the temperature is rising. So because of that, it's going to be 1 degree Celsius. So we know that delta T is going to equal 1 degree Celsius. So we've got two things, but we don't know M. So right now we've got Q equals M times C times delta T, and that's going to be Q equals 4.184 joules per grams degrees Celsius times 1 degree Celsius. So already we can see that our degrees Celsius are going to cancel, but we need to get this in terms of joules, so we need to cancel grams, and clearly we're going to have a mass in terms of grams. So now let's determine our mass. Well, how do we get our mass? Well, let's look at the dimensions of the pool. The pool is 4 foot deep by 20 foot wide by 75 foot long. So we've got 3 dimensions here we're talking about. So we need to talk about volume. So if we think about volume here, we can say the volume of this pool is going to equal 4 foot times 20 foot times 75 feet. And basically this is going to give us the total volume of water of this swimming pool. And of course this is going to be in terms of feet, so we're going to have to do a little bit of calculating in terms of meters and centimeters and all that to get us to the correct calculation we need for grams. So if we calculate this here, we're going to get a value of 6,000 feet cubed. Now it's important to make sure we keep the units for cubes, or for the exact degree, I should say, for the unit. So we've got 6,000 feet cubed of water in this pool. So now I need to convert this. I need to get feet in terms of grams, because remember, we're going from feet to mass. And what do we know? Well, we know that grams is equivalent to centimeters cubed. We know that we can get centimeters from inches. We know that we can get inches from feet. So that's going to be my plan. My plan is going to go from feet to inches, from inches to centimeters cubed. Now remember, this is all going to be, I should rewrite this as feet cubed, inch cubed, centimeter cubed, and to grams, because we know grams is equivalent to centimeters cubed. So let's think about how we're going to do this here. So if we start with 6,000 feet cubed, we can multiply. We know that 1 foot cubed is equivalent to 12 cubed inches cubed. Now notice I'm doing cubes for each individual term, but I want to transition over to the next thing. Well, I know that inches can go into centimeters. So how many centimeters are in an inch? Well, 1 inch cubed is equivalent to 2.54 centimeters cubed. Okay, so we're just about finished. Now the last term I want to do is I want to get this centimeters cubed into grams, and I do that by saying that 1 gram is equivalent to 1 centimeter cubed. These are all the transitional components we need, and as you can see, the feet cube is going to get away, the inch cube is going to go away, the centimeter cube is going to go away, and my only unit left is grams. Excellent. We need that because we need to get rid of the grams down here for the Q. So when we calculate everything together, we're going to get 6,000 times 12 cubed times 2.54 cubed. And all over down on the bottom, we've just got 1 cubed. Or essentially, this is actually 1 to the 6th if we calculate these two things together. So essentially, when we get all this calculated, what we're going to get here is we're going to get a value. I did a pre-calculation ahead of time. I'm going to get 1.7 times 10 to the 8 grams. So this right here is the amount of grams in this water based off the amount of volume given. So now I know all three of my units for Q. Now I can solve for Q. So let me go ahead and just make a little space here. I'm going to erase this conversion table. And when I do this, what I'm going to have now is Q. Again, Q is equal to MC delta T. And again, we know now what the, we already knew what C was. We knew what delta T was. And now we know what mass is. So let's go ahead and calculate everything together. So Q is going to equal 1.7 times 10 to the 8 grams. C is going to be 4.184 joules divided by grams degrees Celsius. And my delta T, we said, was 1 degree Celsius. And let's see if we can get rid of all the correct units. Grams goes away. Degrees Celsius goes away. This is perfect. I want this in terms of joules because that's the measurement for energy. So now we're going to just calculate everything together. So what do I have? I've got 1.7 times 10 to the 8 multiplied by 4.184 and then just times 1. So when I calculate all this together, I'm going to get a final value of 7.1 times 10 to the 8 joules. And this is the amount of energy that is required to heat a pool of that size to 1 degree Celsius. So imagine how much energy is used, by the sun every day that we, if you go from night to day, how much energy is used by the sun to just heat up a pool of water. So this gives you an idea of just the amount of energy it takes to do something of this magnitude. All right, that's it for this problem.